Hello everyone, this is Deep. This video is part of my physics reassessment quiz, and in this video today I'm going to talk about frictional force. We have a problem concerning frictional force in which I have been given a wooden block of mass 4 kg which is slided along the horizontal floor and with a certain coefficient of friction with the initial velocity, and I am asked to find in first part how long does it take for the block to come at rest and the distance covered by it during that duration, and in second part I am asked if another block of same mass is kept on top of it, how long does the block take to come at rest. So to solve this question I have drawn a free body diagram over here, and here R represents my normal contact force, which is equal to the weight of the object, so in this case mass of a block times gravity. Now we know that by the momentum principle, change in momentum is equals to net force times change in time. So in x direction del px is given by minus u k, that is coefficient of friction, times net force times del t, and similarly in the y direction change of momentum is equals to net force minus mg times del t, which is equals 0, which means we have no change of momentum in the y direction. And we also know that change in momentum is equals to mass times change in the velocity in that direction. So I calculated del t from equating change in momentum equals minus coefficient of friction times normal force times del t. So when I plugged in all this value, I get change in time is 1.22 seconds. So it takes 1.22 seconds to come at rest. Now in second part, we know that the net force is constant during that motion. So my average velocity in this case can be calculated by adding the initial velocity and final velocity and dividing them by 2, which means in general sense taking their average. And I also know that the average velocity can be found out by dividing the displacement over time. So my average velocity is 6 plus 0 over 2, that is 3 meters per second, and my change in time I calculated in first part and I multiplied by it, so I have the change in displacement which is 3.66 meter. Now in third part I have been given a same block of mass and it is kept over it, so my total mass, they would be added here. We know that the coefficient of friction doesn't change in this case because the coefficient of friction only deals with the surface of that wooden block and the horizontal floor. So but my normal contact force, it changes. It will be twice, which is given by here. Now applying the same method of part 1, I calculated the change in time, which is the same 1.22 seconds. So we can figure out from this way that even if we add the amount of masses, the time that it takes doesn't change, given that it is pushed by the same initial velocity. I hope you like this video and I think this would be very helpful to you. Thank you.